the variable rate spraying. I'm going to give that presentation, and following me will be Yu Jiang on some more of the engineering aspects of it. So this part of the project has been worked on the most by Brian Lawrence, who has been a postdoc in my group, but he has moved on to other endeavors as of the end of the year. And so he, probably more than anybody else in the entire country, has the best knowledge of variable rate spraying. So I hope we can get him back into this work area sometime in the future. The idea of variable rate spraying is to apply a different dose of chemical to each tree based upon its flower density. This requires then mapping the orchard at bloom, or say late pink to early bloom, or full bloom, developing then a task map from that camera map, and then putting that into a computer-controlled sprayer, and then applying different amounts of chemical to each tree depending on what the blossom load is. This is just a short video of our work here with the Mooncalf sprayer a few years ago. It wasn't at bloom, but we were trying to make sure we could hit a particular tree. So as this video goes, you will see the sprayer turn on and off when a certain tree is reached. So that leads us to this sort of explanation of how the whole system would work. You first have to acquire images, and we currently are working with these 4 companies: Vivid Machines, Outfield, Orchard Robotics, and ARIA Imaging. Outfield is a drone-based system. The others are ground-driven camera systems. But in all cases, you have to map the orchard. Once you have the map with a georeference location for each tree, you have what's there in the second panel, and you have to, from that map, generate a task map. This is one of the blocks at Geneva showing variability in bloom across a bunch of varieties in that block and a bunch of rows. The companies or organizations that will take a map that a camera system develops and convert it into a task map for a sprayer, or the ones we've worked at least, are AgroManager, Raven, QGIS, or ARIA Imaging. We then take those task maps and put them into the computer of a sprayer, and we've worked primarily with 2 sprayers: the Mooncalf 3-row sprayer, computer controlled, and the HSS sprayer, also from Holland, but sold in North America by Bartlett Company out of Ontario, Canada. And we've worked successfully with both of those sprayers to put on variable rates. Now, in this particular case, we show the 3 different types of maps. The first map is the actual orchard mapping. The second map is taking that data and categorizing each tree. Now, one of the things that has been an education for me is there's a whole range of blossom loads on trees across an orchard. But for variable rate spraying, you have to condense that whole range of different numbers of blossoms down to either 2 or 3 categories. So you would then take every tree and put it in either high blossom load, medium blossom load, or low blossom load. And so it's not necessarily so critical to have an exact count. You have to have relative differences, and then this middle task of putting them into one of the 3 categories would then guide the sprayer to turn on or off on the different types of 3 categories of trees. Now, that simplifies in a way that the initial data that's going in. And so we've had great luck with either drones or ground-driven cameras to get us these different levels of blossom density, and then categorizing the trees into one of 3 blossom loads. We had our first experience as a failure because I can't remember who said it earlier, but we couldn't hit the right tree. And small little details that you think are easy, which are the GPS coordinate of the tree, And the sprayer being able to identify that exact coordinate and turn on and off for the tree proved to be a whole year's of work of failure. We then worked with the companies and with Yu Jiang, who's an expert on GPS, to finally figure out how to hit the tree. And this is a successful test where we put up spray cards and programmed the sprayer to turn on and off for that tree, and then quantified how many dots were on the spray cards, which is the red line. And you can see that it turns on right in between two trees. You get most of the tree receiving the full dose, and then it turns off at a little bit slower rate as the sprayer passes. I want to comment that when you're driving 4 miles an hour, the physics of an electronic valve turning on and turning off mean that there will be several centimeters or a foot or whatever of travel distance in the time that the valve is turning on and off. And so there is going to be a challenge, I think, hitting individual trees when the planting spacing is very close. This is a 3-foot spacing illustrated here. When you go down to a 2-foot spacing, it will be, I think, challenging to hit an individual tree. And so my thinking on this whole variable rate spraying in the last year and a half has changed from wanting to have an individual tree sprayed to having a section of row sprayed. Now, the section of row could be as small as 3 feet, could be 6 feet, whatever. But that allows several different approaches to measuring blossom density. Now, the blossom maps that we've used have been developed by both drone and cameras. The companies that we've successfully worked with, I've already mentioned. We have not worked successfully with Green Atlas. They do not provide an individual tree blossom number. They provide a section of row, but with the physics that I just described on trying to hit an individual tree, it is also a system that will probably work with variable rate spraying if the length of row section that they're mapping is small enough. I don't think that having a 30-foot length of row is going to be useful for variable rate spraying. And we'll get to that in just a minute. But in our case, the several experiments that were done by Brian were very successful. And I'm going to report specifically on 2 of them here. One where we used a drone and used a section of row, essentially the distance between 2 posts, which is 30 feet, and where we used individual tree data to try to hit a single tree on and off. This particular task map was one where it's a 3rd experiment, I won't spend a lot of time on it, but the first map on the left shows that there's relatively few trees that had low bloom. So it was a Honeycrisp orchard. We were trying to thin variably, but it had really good bloom on almost every single dang tree. And it turns out that under that situation where the bloom is uniform, variable rate spraying is less valuable and maybe not worth the effort. Variable rate spraying is most valuable when there's variability in bloom intensity down the row. So the map on the left is converted to a task map in the middle showing high, medium, and low. And we did on 3 different Honeycrisp rows, and we can show that it should have different levels of spraying. In this particular experiment, we used the HSS system you see pictured on the right, but the data at the end of the year didn't really show us any great improvement on yield or fruit size between a standard spray up and down the row uniformly versus a variable rate spray, because almost all the trees were heavy blooming. There's a short video showing just on and off of the HSS system. Now, this particular sprayer uses variable nozzles, PWM nozzles, which would allow separately to spray the top of the tree to the bottom of the tree. Whereas most other sprayers, it's only an entire bank, either on the left side or the right side of the sprayer, gets turned on and off at any one time for any one tree. When we looked at trying to quantify the number of fruits using either ground-based, in this case, Vivid machines versus outfield, on the left, you see 3 different timings of scanning the orchard with Vivid machines. The first was before any fruitlet thinning sprays were done at petal fall on 10 millimeters. And you can see a vast distribution of the number of fruitlets going from as low as 45 fruits per tree up to some trees having 600 or 700. But after the first variable rate thinning spray, that distribution was much more compact, with ranging from 45 fruits up to maybe 200. And after the second thinning spray variable rate, we were able to get a much narrower distribution of fruits. We did the similar sort of thing with outfield, a drone-based system, and the chart on the right shows that the initial outfield estimate of numbers of fruits after thinning, this is when fruitlets were 30 millimeters, was not so accurate compared to the orange box of orange. But when we applied a correction factor, then we could get a very good agreement between the ground truth number of fruits per tree and the outfield measured number of fruits per tree, although the variability in the estimates with the drone was more than the variability from the fruit numbers made by hand counts. Now, I want to describe these next two experiments a little better. This one was done at Rod Farrell's orchard called Lamont Fruit Farms in Western New York. They have a 2-foot spacing system, a super spindle system, and we decided, along with outfield, to map the orchard and assign a blossom density score to each panel. Now, each panel is 30 feet long, so that's a significant number of trees within each panel, and we were giving an average score for that panel. Now, one of the problems with this is some trees might be heavy blooming and some might have no bloom, and the average score would be medium bloom, but we were going to spray the panel according to the average blossom density. Brian walked that orchard and gave his own Cornell visual score to each panel and compared it against the outfield camera developed score for each panel. And that's the first chart on the left, showing a relatively good relationship between what they scanned with their camera and what we saw with our eyes. In the second panel, we compared, after the thinning was done, at around 30 millimeters, how many fruits there were per tree versus outfield with a drone estimating the number of fruits per tree. And that relationship was good, decent, but not as good as we would like. If we just averaged the whole panel against the Cornell measured whole panel in the last chart on the right, then the relationship was very good. But here it illustrates again that a whole panel is quite a big distance to average all the trees within it, especially when you have variable bloom in a Honeycrisp orchard. Since we did this study in 2025 and later in the season, working with outfield, and Rod Farrell in particular have developed this, they've been able to say, take a 30-foot scan of the picture of a 30-foot scan from post to post and chop it into 3-foot sections and then treat each 3-foot section differently. Score it for blossom density, high, medium, and low, and then spray it differently with a variable rate sprayer. And that's what we hope to do next year instead of using a whole panel's distance. The more successful study was done here at Geneva with a row of Golden Delicious, which had variable bloom. We wanted to do this with Honeycrisp, but all our Honeycrisp had too much bloom. They were all heavy blooming. But in the golden row, we had variable bloom. And so we then scanned this. In this particular case, we were using ARIA imaging and their drone ID system. And in the chart on the bottom left, you see how many flower clusters we counted per tree and what the drone saw in blossom load at blossom time, because we wanted to use a blossom map to then guide the sprayer. And you see up in that upper two pictures on the left, what the blossom map versus the task map shown on the right. We then categorized trees into two types after we took the drone image, and we categorized them in either high bloom or low bloom. In the first figure on the left, the blue diamonds are the low blooming trees, and so they generally had less than 100 flower clusters. All of the open red boxes are the high ones we categorize as high blooming. And so that categorization from the beginning ended up at harvest with different numbers of fruit per tree. The low blooming category tended to have fewer fruits, and the high blooming category tended to have more fruits, even though we sprayed the high blooming category with the variable rate spray, and the low blooming were not sprayed as we drove the sprayer past those trees. The second chart shows the fruit set per cluster. The open red squares show that many of the clusters had one fruit, some had less than one fruit. A few of the open red squares had a fruit and a half, but the low blooming trees that were not sprayed tended to have some a single fruit per cluster, but many of them a fruit and a half or two fruits per cluster. When we harvested the fruit, we separated the trees into either the high blooming group or the low blooming group. And each one of those groups was either sprayed standard, where we sprayed the entire row, or variably rate sprayed, where only the high blooming trees were sprayed. And you can see among the high blooming trees, which all got sprayed, whether it was a standard sprayer or a variable rate sprayer, we had similar kilograms of yield. But in the standard spray, the low blooming trees got sprayed and they were thinned down to about 8 kilos per tree. Whereas in the variable rate, the sprayer skipped those and we had around 12 kilograms of the low blooming trees. That difference is the dollar value of variable rate spraying. It's most valuable when you have variable bloom and you can spray trees differently. Now, for many sprayers like the Moonkopf, which was used in this, if you wanted 3 levels of spraying, you would go through the orchard once with one map and spray all the high blooming trees. Then you'd go through the orchard a second time with another map spraying only the medium blooming trees. And then the low blooming trees, of course, might not get any spray. So that's a little more complicated because you got to drive through the orchard several times. If you have the ability to have PWM nozzles, you could apply 2 different rates on a single pass. But we wanted to demonstrate the idea, and I summarized some of this variable rate work, which has taken a lot of effort because we just didn't seem to get the GPS part of it worked out in our first few years. But it is possible to spray variable rates on individual trees, but the GPS mapping has to be very precise. Brian's got it figured out. He's the guy in the whole country that can do it the best, along with the people from ARIA and the people from HSS, the Bartlett people out of Canada. Now, variable rate spraying will be most useful as we move forward where blossom density is variable along the row. It is less valuable when everything's blooming heavily. Now, example of this benefit, which I want to just point out here with some dollars. Let's suppose you have Honeycrisp that has a target of 100 fruits per tree. And for the sake of argument, let's say 50% of the trees in the row have more than the target. Suppose you pruned at 1.5 and your target was 150 flowering clusters. Let's say 50% of the trees have more than that. Those should be thinned aggressively. And hopefully, if you do a good job, you can get it down to singles, and that would account for 50 fruits on each tree. However, the other 50% of the trees are lower than the target number of blossoms. They shouldn't be thinned so aggressively. They should be thinned so that they end up with doubles. In that case, if you had only 25 flowering clusters, but each was a double, you'd still end up with 50 fruit. So with the high blooming trees providing 50 and the other ones 50, you'd still have your 100 average per tree. Now with conventional spraying, you would spray them all and you would overthin the low blooming trees and get the other ones about right. So let's suppose you end up with 75 fruits on average per tree. At a tall spindle spacing of 3 by 11, that's 1,320 trees to the acre, the extra 25 fruits from variable rate spraying would amount to 33,000 more fruits per acre, about 16 and a half bins, and at $400 per bin, that would be about an extra $6,600 per acre by variable rate thinning. That's a significant amount of money and can be the difference between profitability and not profitability, especially when you have a year where honeycrisps bloom variably. The same could be true for Fuji or any other variety that has variable bloom. So let me just sort of wrap up this variable rate spraying concept. I think it's got tremendous value. We've begun working with a number of different sprayer manufacturers and sprayer controller companies to try to extend this kind of technology to more growers that might not have either a Moonkopf or an HSS computer-controlled sprayer. The little things like getting the GPS to match up so the sprayer sprays the right tree turn out to be bigger problems than I ever imagined. And so what Mauricio Guerra said earlier is there's got to be some hands-on grower help to get them going in their orchard. It's not going to be so simple just to say, here's a sprayer, go spray. They'll be not sure they're spraying the right trees. In fact, we have several growers in New York that are ready to start variable rate spraying, but they're fearful they won't be hitting the right trees unless Brian or I or somebody goes out to help make sure of that. They're unwilling to try it. But specifically, we're enthused that with a Raven controller, we've been able to run a Durand Whalen sprayer. With Red Ant sprayers, controllers, we've been able to run other sprayers. We're going to work with the VineTech sprayer company. They've got their computer controller now able to take a task map on blossom thinning, along with the ones that we've had success with, which is the Moonkopf and the HSS sprayers. We've worked and talked a lot with John Deere, who already has a spray system for on and off when there's canopy, but they have been unwilling yet to invest the time to program their computer to take a blossom map, which is different from their spray system that they're using right now. I'm going to end up with just a couple of comments. After chemical thinning, you can use cameras to guide hand thinning. And this is a picture showing trees along a row in the Hudson Valley where we scanned with Orchard Robotics before thinning. That's the yellow peak, jagged peaks. And then we calculated how many fruits should be left. That's the black line. Then we hand thinned by just standing there with a clipboard and telling them on that tree, take off 50, on this tree, 100, on that tree, 35. And then the red line is what we observed when we rescanned after hand thinning. And it's relatively good match. Not perfect, but some of it might just be hand counting, which also has error. But nevertheless, that hand thinning point is when you can make the final adjustment to get the proper fruit number on every tree. The problem is we don't have a way yet to tell the worker how many fruits to take off without somebody standing there with a clipboard and telling him how many to take off. So in the meantime, these camera systems are getting better at telling us how many fruit we end up with after hand thinning. But to really make it a useful thing, we've got to be able to communicate to the worker what to do for each tree. In the meantime, some growers have used these maps just to go out and focus their hand thinning efforts in certain areas. And that's what happened in 2025 with this grower. He targeted the area in the red box, told his thinners to just work in that area, and then rescanned after their hand thinning. That's the second map, and you can see much more uniform fruit number with just the targeted hand thinning. 3 final points. Precision pruning is required, I think, to get the optimum number of fruits per tree. People who don't want to invest time in precision pruning, I think, are going to be frustrated. Secondly, variable rate chemical thinning is possible and I think is a wonderful thing as we move forward. It can be done with data for a section of row as long as the section of row is not too long. And so I'm very enthused about getting the data either from drones or ground-driven cameras for a 3-foot, 4-foot section, and then just categorize it high, medium, and low based on that section, and then run the sprayers based on that map. And lastly, precision hand thinning, I think, requires individual tree data, not just by zone of the row. So precision pruning requires individual tree, and precision hand thinning requires individual tree, whereas variable rate spraying can be a more zone along the row. So that's where I'm going to stop right now, and I'm going to go ahead and ask Yu Jiang to go forward with his part of the presentation. Then he and I will both take questions.